And let's welcome Joan.
Hello, everyone. Okay, there's still some people coming in the room. My name is Joan Ruiz. I am a system engineer manager at Fortinet. I'm based here in Barcelona. I work with my team of system engineers and the account teams in the local team here. And today, I'm going to be talking about artificial intelligence use cases related to cybersecurity. If I was a marketing guy, I would say that probably AI is one of the most transformative inventions that's going to drive the innovation in the future. It's likely one of the fastest growing technologies that will soon have more than 1 billion users using it every day. The reality is that this is a very trending topic in AI, but I'm not the marketing guy, I'm a system engineer. So today, I'm going to be presenting you some of the real things you can do with AI today. Just to get started, I'm not an AI expert. I'm more a cybersecurity expert. So I'm just going to be touching a brief overview regarding some of the key technologies that are underlying in the artificial intelligence field, so we can see and understand how can we take benefit of those technologies in order to have better protections of our systems. So first of all, I would talk about machine learning. Machine learning is one of the subsets of AI which tries to create some systems that are capable of getting some inputs, applying some specific processes, and then get some outputs with an outcome, trying to automate all the stuff. Basically, there are two types of machine learning, supervised and unsupervised systems. In a supervised systems, you need to enter some inputs in your system which are labeled. For instance, you need to enter clean files and malicious files to the machine learning engine. Then this engine can understand which are the features and the capabilities of clean and malicious files, and then get an outcome. So this is supervised. Unsupervised is another type of systems where you don't really need to tag or label your data. You just enter some data into the machine learning engine, and it's able to do some processing, some classification, some grouping to try to get some features or characteristics of the different artifacts, and then take some conclusions relating on that. Deep learning and artificial neural networks is another type of machine learning, a subtype of machine learning, more complex systems. In this case, we construct systems that try to mimic or replicate the logic of our brains. So basically, we build systems that have millions or billions of processing nodes, and then we get some inputs into those systems with sometimes some hidden layers in the middle that do some calculations and can do much more complex stuff with that. And then we have the LLMs, the large language models, which are the enablers of the Gen AI technologies such as Google Gemini or ChatGPT. We all know all about that. And the bad guys also know about that. So we, in our threat intelligence, are starting to see how the bad guys are trying to take benefit and exploding artificial intelligence technologies to do some of the bad stuff. For instance, we are seeing more and more deep fakes. With the advent of AI, it's much more simpler today to create a fake voice or fake video. Recently, we've seen some attacks where a malicious actor has been able to do a Teams call with real-time fake video to try to steal some money, faking to be one of the managers or the CEO of a company. This is something that we are seeing today. It's happening now. AI will enable the malicious actors to get better password cracking techniques, to have easier and faster malware construction, and also some other malicious activities. Bots and botnets is some of the bad stuff that we are seeing today. It's hard to differentiate humans from bots. With artificial intelligence applied to botnets, it's going to be more and more complicated. And we even see LLMs used for the recognition phase of the attack. So attackers are relying on LLMs to grab information from your company, vulnerabilities, your employees, your staff, and try to build everything and get it ready to prepare an automated attack for that. This is Worm GPT. It's a bad stuff GPT. It's a tool that's available, you can Google it, and it's an uncapped LLM able to create malware or many other features. It's just out there, you can use it. Okay, now that ChatGPT and all other LLMs are so trendy, we can ask a question. Can an LLM system be attacked? The reality is that yes, it can. So this is the basic architecture of an LLM. An LLM or any other artificial neural network is a system where you can see some training data you need to enter. In the case of LLM, it's massive amount of data. Then you have some training algorithms, and you are able to produce what we call a trained model, which is a model capable of performing some specific tasks. This system needs some inputs, such as the training information, or in the day-to-day users, you have some inputs, such as text, voice, video, images, and then you get some outputs. All these points of interaction can be easily exploited by attackers. And when I say can be, I mean they are being attacked. Maybe you are not aware of OWASP. OWASP is a well-known organization which tackles about known vulnerabilities for web application systems. We will discuss about that later. Well, OWASP has recently published what they call the top 10 LLM model application attacks. So this is recognized attacks that we are seeing today in the field, such as command or prompt injection, such as trying to manipulate the LLMs to get some internal training data, or maybe even trying to steal the full application trained model. So we are seeing many types of attacks, including training data poisoning, for instance. Maitre is another well-known organization. You may know it by the Maitre attack command and control techniques and procedures. Maitre has recently published what they call the adversarial threat landscape for artificial intelligence systems. This is a good repo about techniques and tactics that the bad actors can utilize in order to exploit LLMs. So you see a lot of green stuff there. So we are seeing really, this is a very vivid moment. And I hope we will not fear our friends from Cyberdyne Systems in the future. You know, Maitre is now working with the NATO and other security organizations worldwide because AI can really be a concern and a threat, not only for cybersecurity, but for many other fields in the use cases. So what I am going to be presenting now is some of the use cases that we at Fortinet can utilize AI in the cybersecurity space in order to do some specific stuff. It was quite difficult for me to build these presentations. I could look into more than 50 documented use cases at Fortinet, and I just picked 10. So I'm going to be presenting 10 quick use cases of AI-enabled cybersecurity utilities in the cybersecurity space. And let's start by the beginning. So how would you ingest petabyte of data into a system and then be able to extract actionable data in order to have better intelligence with AI? Well, Fortinet faced or started to face this problem like 12 years ago. Fortinet is, maybe you don't know, but Fortinet is the, according to IDC, we are the leading firewall vendor in the world, accounting for more than 50% of all the firewall units ever shipped. What does it mean? It means that it has more firewalls in the field than all vendors together. And this gives Fortinet a huge amount of data of what's happening in the field every day. We are getting all that data, telemetry, all that feeds, information, artifacts, and we are sending that to our threat intelligence, which is FortiGuard Labs. 12 years ago, we started to realize that we were getting so much data, processing petabytes of information, that we could not cope with that, and we needed to do something. So we started utilizing AI techniques internally. So not as a product that we are selling to our customers, but an internal tool that's able to ingest all that data and provide the actionable outputs, such as the indicators or the threat intelligence. Here you can see a list of some of the things that we are producing in our threat intelligence, such as IPS signatures, anti-malware signatures, DLP, CASB signatures, botnets, indicators of compromise, outbreak alerts, and many other indicators that help organizations to be better protected. We do all that with AI. So basically, 12 years ago, we started building a multi-layer system that's able to ingest all that massive amount of data and then, through different layers, automatically extract the signatures of the malware, of the URLs, try to do the categorization, and then have a secondary AI system which is reviewing the integrity and the quality of those feeds. So this is going live for 12 years now, and it's protecting all the install base of Fortinet customers so far. One of the interesting use cases that we can do with AI is try to help organizations protect against vulnerabilities. You know that every day vulnerabilities are being published, and there are so many that many people is overburdened with that amount of work to do. Good news is that only 3% of the critical vulnerabilities that are being published every day will end up being utilized by the threat actors in order to do some exploits. Only 3%. If we could guess which of the 3%, which of the vulnerabilities are part of those 3%, our life would be much easier. Well, this is what we try to do in collaboration with the FIRST. FIRST is an American organization, a non-profit organization about cybersecurity. You may know them because they held the CBSS, the Critical Vulnerability Scoring System. So together with Fortinet and some other vendors, we are working in an initiative which is called the EPSS. So it's the Exploitation Prediction Scoring System. And what's this? It's a machine learning engine that will utilize the CBSS Critical Vulnerability Scoring System and additional information in order to predict which vulnerabilities will most likely be exploited by the threat actors in the next 30 days. This is what we do. We at Fortinet are providing massive amount of data to this machine learning engine that's calculating and is taking into account the criticality of the vulnerability. If Fortinet is seeing activity and exploits in the wild, if we see Twitter messages or messages in the darknet, if are there any exploits available, if Metasploit or some other offensive tools are loading modules with those exploits, and we start to see what is the likelihood of vulnerability that will be effectively exploited. So we can get better protection and prepare our customers. What we do at Fortinet is we publish the outbreak alerts. This is a sample we published last week. It's regarding Black Basta ransomware group. Black Basta is one of the worst ransomware groups in the world. We are seeing more than 500 critical infrastructure customers being impacted by the ransomware group in the last weeks. So what we did is we realized this has an EPSS score of 96.73%. This outbreak alert was published last week. What does it mean? It means that with 96% of probability, this exploit is going to be utilized to attack customers in the next 30 days. So you better get ready for this and be prepared. Once we know this, we prepared the outbreak alert package with all the signatures and the protections that the customer needs to be better protected to be able to handle that vulnerability even before it happens. So that's kind of magic. Next, the next use case is about malware and 0 days. You know that malware is something very dynamic. We at Fortinet utilize a multi-layer architecture in order to tackle with malware. What you see in this white box is our flagship product, the FortiGate firewall. The FortiGate utilizes a layered architecture of different systems that are able to detect the malware. First of all, starting from the top, let's see if this works, we get the standard antivirus signature system, which is almost useless today. And then we filter the known bad stuff. Then we go through some engines that do the heuristics, try to determine and extract the malware characteristics. And at the end, we come up to this engine here, the green one, which is an AI machine learning engine, which is loaded in the FortiGate firewall. This is a system we created with neural networks in FortiGuard Labs, and we include that in the firewall. What does it mean? The firewall is able to process with a binary that's able to extract information and metadata of the malware to try to detect good and bad stuff. If that's not enough, we have a cloud service, which we call the FortiSandbox, where we can send the suspicious files to do some additional static and dynamic analysis of the malware to detect the behavior and see if the stuff is good or bad. You know, we are taking very seriously and try to provide as much information to be able to detect malware. And this is the most advanced malware detection technology that we have. It's a patent in the US, and it's an artificial neural network that what's doing is it's taking 20 years of history of the FortiGuard Labs threat intelligence and putting that in a box that you can install in your data center. This is what it is. This is a neural network where we have the files or network traffic that we can introduce in our neural network system. We decompose that into small blocks, typically 3,000 blocks per file, and then we introduce that into a machine learning neural network where we can try to look for good or malicious activity or artifacts within those files, and then try to classify and provide a verdict. Is that file clean or is not? Is it malware? We can actually classify more than 20 types of malwares, such as ransomware, worms, botnets, destroyers, exploits, data leaks, phishing attacks, or many more, extracting the characteristics of the malware. And how we do that? The neural network is able to provide an output, and in this case, this is a sample of a zero-day ransomware. We can say, okay, I found 660 characteristics of a downloader, a ransomware, a Trojan. We can even extract Mitra attack techniques that are utilized in that binary. And this is what we do to detect malware in 0 days. Another use case is utilizing AI to protect web applications, which is a totally different approach. For web applications, we typically have the web application signatures, which are useless today because are very easily fuzzing. And then we have the traditional learning algorithms that are being replaced by machine learning algorithms. What we do to protect web applications is a dual system of artificial intelligence with machine learning with 2 layers. The first layer, we have all the application data traffic that enters into the web application firewall system. And when we utilize a machine learning anomaly detection engine. This engine is able to distinguish regular traffic and anomalies. An anomaly is not necessarily an attack. It's just an anomaly. So we introduce all the anomalies in a second layer, which is the threat detection layer, another machine learning engine that's able to get anomalies and do the investigation to detect the bad activities and the malware. Inside this second module, we have different trained systems that are able to detect multiple well-known application attacks, web applications attacks, such as cross-site scripting, command injection, or many of the cross-site scripting, or many other attacks. So we introduce the traffic in the machine learning system, and it's able to extract the features and the characteristics. Is this an SQL injection? Is this a highly suspicious code injection? Is this good or is it bad? So machine learning helps us distinguish good and bad stuff in web applications. Next use case is about bots. I may surprise some of you with the next slide. You know, a bot is a system that gets zombie computers in the internet to do some bad stuff. Bots can be utilized for crypto mining or throwing DDoS attacks or scrapping webs, many other stuffs. If you look at the real internet traffic today, you will be surprised that almost 50% of the internet traffic today is done by bots. There are either good and bad bots. So real internet traffic is just 50%. And I must tell, I should update this slide because maybe with the LLMs ingesting all that data from the internet, this is even worse today. Bad bots can scrap all your web application and try to extract information to build phishing attacks or some other kind of attacks. So this is real bad stuff. And bots are getting more and more smart. So what we did at Fortinet is to create a machine learning system that's able to identify the traffic of a web application, and we try to distinguish, is this a real human utilizing the application, or is this a bad bot? What we do is a multi-layer approach where we had good non-signatures for good and bad bots, such as the Google bot that is indexing your website to publish it in the internet. We don't want to block that. Then we have some fingerprinting mechanisms, biometric-based detection, so we can see, is the mouse moving? What's the speed of the keyboard typing? Is this human or not? And then we have a scoring system with AI, try to distinguish if this is a real human or not. I must tell that bots are getting smarter. So now bots can mimic the real behavior of a human. It's more and more difficult today to distinguish the bots. Next use case is try to control data leakage with the LLM. So all the companies are scared today that their users may be utilizing Google Gemini, ChatGPT, or some others to load it with corporate information that could be leaked into the internet. So this is a real concern. What can we do at Fortinet? We can do many things with that. First of all, we have included a web filter detection mechanism for well-known artificial intelligence applications. So we are able to block specific applications to restrict the usage. In this case, user is trying to type text into Google Gemini. It's not able because the firewall is blocking. But it's not only about allowing or blocking, it's also about data leakage. What we are doing, and this is something we are working on, is to utilize LLM systems, so machine learning systems, in our DLP scoring system, so we can understand if the things that your employees are typing in the Google Gemini or ChatGPT is some proprietary stuff of your organization that I should block. So utilize machine learning to try to avoid your users to leak information to machine learning tools. This is what we do. Next use case is about threat actors. So can we utilize AI in order to detect threat actor bad behavior? What we do is we have different systems that utilize artificial intelligence to detect bad behavior in the bad actors. In this case, our EDR solution, FortiEDR, is protecting our users with artificial intelligence in order to detect behaviors that are malicious. So you know that the attackers are getting more smart, and 90% of the more sophisticated attacks, 90%, almost all the attacks, are not utilizing malware today. They utilize techniques that we call living off the land, which consist on utilizing the regular applications of the operating system to perform the bad behaviors. And can we do that detection in places where the EDR is not available? Yes, we can. So in the situations where you cannot install an EDR solution on a desktop, we have a similar technology which is called NDR, Network Detection and Response. With NDR, we can ingest data traffic from the network and act detecting those malicious behaviors in the real network traffic. So even for devices that don't have any EDR, we can do detection based on behavior and machine learning to detect malicious activities. And finally, the last couple of use cases are about SOC augmentation. If you're interested in SOC augmentation with AI, the next presentation that will happen in an hour from now is going to be tackling that as well. So typically, alert fatigue, skill shortage, attack sophistication are one of the most concerning pain points of the SOC organizations. We try to utilize AI in the SOC to streamline, to automate the processes of cybersecurity, trying to detect false positives and to reduce the investigation and the contention times. We can do many things in the SOC with AI. This is one of the nice things we can do with our SIEM solution for eSIM. We include a machine learning workbench in the SIEM. I must tell, this is not something easy to utilize. You must have some data scientists or AI engineers in your company to be able to take benefit of this. What we do is we train the models and try to detect anomalies. And I try to explain with a simple example. In this case, imagine we have a set of users that are regularly logging into different machines. And from time to time, there are anomalies of users that may connect to a machine which is not typical. And this is something that we can do with AI. And how we do? This is the SIEM. We will utilize the machine learning workbench in order to create a training system. We will train our artificial intelligence engine with all the logging data for all the systems in our network. And then we will try to produce an output to detect those anomalies. In this case, we are running now. This is an automatically report that is built into the SIEM. And now we are training our machine learning engine with all the login information of the users, the machines, IP addresses, time frames, to try to detect all kinds of parameters and behaviors so we can detect what's going on and we can distinguish the regular users and detect anomalies. For instance, if one of my credentials has been leaked and one user is connecting or bad actor is connecting to a machine. In this case, we finish the training and we see 48 users were trained in the systems, and we were able to detect 5 anomalies of those users that were able to connect to machines that were anomalies, were not something regular. So this is something that the SOC will investigate. Imagine doing that by hand. Machine learning can have a lot of benefit and utility in these kinds of exercises. Another thing we can do in the SOAR is try to automate all the investigation, remediation of the SOC with machine learning. FortiSOAR, which is the SOAR of Fortinet, includes a machine learning engine that can automate a lot of stuff. For instance, it can suggest which playbooks to utilize in an investigation. It can suggest to aggregate different alerts or incidents that are similar based on machine learning. Or we can even have some use cases such as phishing email triage based on machine learning engine. So we can receive a copy of the emails in the SOAR, and it will automatically do the investigation with machine learning to detect if this is or not a bot. And I couldn't finish my presentation without talking about Gen AI, because it's so trending today. Everyone is using that. So yes, Fortinet is also using Gen AI. We call it the FortiAI Assistant. And this is an AI system that is being deployed in many products across the Fortinet portfolio. It's already live in the FortiSIEM and in the FortiSOAR. It's coming to the FortiAnalyzer and FortiManager and many other products with the FortiAI embedded in the system. We can do many things, such as automated investigation, documentation, and many use cases with the AI or generative AI. In this case, we have a list of incidents in the SIEM, and we can utilize natural language to ask the SIEM, okay, can you analyze this incident for me? Can you tell me which actions should I take? What IPs should I block? Can you see if there are more attacks that are similar? And then the advisor will process automatically. This is integrated with ChatGPT or Google Gemini in the backend. We can also ask, for instance, to do a summary of all the alerts and provide feedback. Can you provide a summary of all the alerts that we have? We can even ask the SOAR AI system or Gen AI system to create playbooks for automated response. In this case, we just discussed with the AI agent about a Dragonfly incident, and we are asking, can you explain me what steps should I take in order to create a playbook to investigate and contain this alert? And not only it is explaining step by step what to do, it's actually doing that. So the SOAR AI agent will automatically create the playbook for you. It's just from language to playbook creation. It's all live now. You can use it. And last but not least, a quick summary. So we've seen 10 different use cases of AI that you can utilize today. So this is not marketing. This is things that you can do today. We've seen how the Fortinet threat intelligence system is relying on AI to ingest data and provide actionable response. We've seen how to protect web applications and bots utilizing machine learning, how to detect bad behavior in the EDR, in the NDR to detect bad actors, and also different techniques that you can utilize to do the SOC augmentation utilizing machine workbench or even the generative AI systems. Final thought on my presentation. AI is not magic. It has much more to do with maths, with statistics, probabilities, and some of the AI applications are consumer ready. It's plug and play. But some other applications will require you to do some homework. So you better get some AI engineers in your company that can take benefit of all of the tools that we are delivering, because some of them require people that know what's doing with them. So I hope you find this presentation interesting. Thank you very much.